this video, we will show you what is the step response of RC circuit and how does it work. First of all, step response happens when there is a sudden changes in a circuit and the voltage and current adjust to the new conditions. If the changes happen in an abrupt or sudden step, the response is called as the step response. For better understanding, we have applied an abrupt step in a voltage to a resistor-capacitor circuit, and we will show you what happens to the voltage across the capacitor. Before we show you what happens to the circuit, we must understand the formula first.
This is how we derive the formula of step response of RC circuit. Based on this circuit, there only have capacitor, resistor, and voltage source. Since the circuit is in series, the current is flow through the resistor and capacitor is the same. So the formula is C dV over dt plus V minus Vs over R equal to 0. We just rearrange this equation, become V minus Vs dV equal to negative 1 over CR dt. Next, we have to do integration to solve this equation. The limit is from 0 to infinity. After integration is done, there's a ln in the equation. It's very simple. We just times exponential to the equation, because ln times exponential is equal to 1. We just rearrange the equation, left V bracket T at the one side, you get the formula of step response of RC circuit.
This switch circuit illustrates the step response in a RC circuit. As you can see, while T equal to T0, the switch closes, causing a jump or step in voltage across the capacitor. As the switch closes at T equal to 0, the capacitor has an initial voltage of V0. The graphs can be expressed as the equation Vt equals to initial voltage of capacitor times time minus initial time. If we wait long enough, the circuit will reach DC steady condition again. Current in the capacitor becomes 0 and its voltage reaches V source, as can be seen either from the circuit or from the expression for VCT. If the switch was closed at time t equal to T0 instead of time 0, the capacitor voltage waveform would be VCT equals to initial voltage minus source voltage to the power of negative of T minus T0 over tau plus the source voltage. These graphs show the voltage and current across the capacitor that are discharging while T is bigger than 0.
Okay, now we proceed to the example of the step response of RC circuit, where it has only have capacitor and resistors. So we have to determine the initial capacitor voltage, time constant, final capacitor voltage, and also Vt and It when t is bigger than 0. So basically, when time is less than 0, the position of the switch will be at position A. The capacitor will be open circuit and the circuit is connected to 30V DC supply. And by using the voltage divider rules, we will get V0 equal to 10V. When t is bigger than 0, the position of switch will change to B. Using the concept of tau equal to RC, we can substitute the value of capacitor and resistor into the equation. So we can get the time constant equal to 4 seconds. By using voltage divider rules, we can also obtain the final capacitor voltage, which is 4 volt. And finally, by using the general equation of V0, we substitute V infinity, which is 4 volt, V0 is 10 volt as calculated just now. Then we can get Vt equal to 4 plus 6 e power of negative t per 4 volt. For I value, we just use the formula It equal to V per R plus C dV dt. Then we substitute the value into the equation and make differentiation, and finally we get the answer is 1.333 negative e power of negative t per 4 ampere.